Welcome back, my wonderful Allen High School chemistry students. We're going to jump right into predicting. Now, synthesis can be pretty complicated, and you will only have to classify the complicated ones. We're going to look at predicting only the simplest of synthesis. So let's take a look at how we would do that. Now, remember, a synthesis is like a marriage. We're going to have two reactants. So my two reactants in this case is potassium. It's a metal that's not mercury, so I know it's a solid. Chlorine is diatomic. Okay, so I have chlorine gas. Now, when potassium goes into a compound, let me use a different color here, see if I can make this a little clearer. When potassium goes into a compound, it wants to become potassium ion. It wants to lose one electron. When chlorine goes into a compound, an ionic compound, it becomes chloride. So often if you write the ions, that can help you. So I would have potassium chloride, and I know that's a solid because ionic substances are solid. Now, since potassium went from potassium 0 to +1, and chlorine went from chlorine 0 to chloride, which is -1, that means the chlorine was reduced, the potassium was oxidized, so yes, this is a redox reaction. And in fact, all synthesis that you have to predict will be redox. Some of the ones that you have to classify won't be, but if you're predicting it, it's going to be a redox. Let's take a look at the next one. I have iron 3 nitride, and it said it's a solid. Whoops, and notice it said it's the only product formed. So let me make sure I put that on the correct side of the arrow. So I have iron 3 nitride formed. Again, the only time I'm going to have to predict a synthesis is from elements. So that must have meant that I had some solid iron and I had some nitrogen gas. Okay? Now, since solid pure iron is 0 and iron 3 nitride is Fe+3, I know that's a redox. All right? So that's how we would predict both of those. Make sure before you're done that you balance. So I need a 2 there and a 2 there, and I would need a 2 and a 2 to make sure I've balanced it. So now that's balanced and predicted. I'm good to go. All right, so synthesis is sometimes a redox, but not always a redox, right? So you really have to look at it carefully to be able to make that judgment call. Okay, we're going to see pretty soon that some of them are always redox. My computer's lagging on me just a little bit here. Okay, so let's take a look at decomp. Now the same thing holds for decomp as we had in synthesis. The complicated ones you will just classify, but if it's simply elements involved, I expect you to predict it. So I have solid lead 2 oxide. Now it's going to decompose, and you notice it said by heat. It's not uncommon to write the word heat on the top of it for a decomposition. Often we want to be something a little bit more simple, and we would put a delta over there to indicate that it was heated or required energy. Now the only ones that you're going to have to predict of a decomp are going to the pure elements. The more complex ones would be a classification issue. All right, now, so lead was +2 here, oxide was -2, lead is 0, oxygen is 0. We did have an exchange of electrons, so yes, this one was a redox reaction. Okay, now let's try this more complicated one that we would expect you to write and balance, but not necessarily predict the products. So this is the decomposition of potassium chlorate. So I would put that in maybe a crucible and heat it, or maybe evaporating dish and heat it strongly. And if I did, I'm going to get KCl solid, because ionics are solids, and oxygen gas. Okay. Now, let's take a look. We want to balance this, and then we want to see if this one happens to be a redox. I'm going to leave the oxygen for last. Let's say I've got 1K and 1K, Cl and Cl. That didn't really help me too much. I have 2 oxygens and 3 oxygens, and so I have to go with the lowest common multiple, and that's 6. So I need a 2, and that gives me 6 oxygens on this side, and I would need a 3, and that gives me 6 oxygens on that side. Now, since we changed some coefficients, you need to double check. Now I have 2 potassiums, and I need 2 potassiums and 2 chlorines there. Okay? Now, in this case, we do have, and this is a little more complicated, but here's your indicator of whether it's a redox. I have oxygen going from a compound to pure. So whenever that happens, when you have a pure element formed out of a compound, that's going to be, yes, it's a redox. What's tough for you to see is that this chlorine also changed, but we're not going to worry about that right now. You can tell because you've got oxygen in a compound, and then you've got pure oxygen. So that means that we have a redox. Okay, we'll continue our discussion in our next set of videos. Until then, this is, as always, signing off.